As we dive deeper into testing, I am realizing that the LTX 2.3 model is far from simple. First off, I noticed that many official control type LoRa's have been introduced. For instance, this union control LoRa brings in the control features we're used to, like depth maps and edge detection. Even better, there is a highly powerful LoRa designed specifically for pose tracking. With these features rolling out, we can be absolutely certain that the LTX 2.3 model will soon support video-to-video generation. However, these features haven't been integrated into ComfyUI just yet. So today, we're going to explore some advanced techniques for the LTX 2.3 model. We'll be using multiple reference images to generate a video. You can simply think of this as first frame, last frame, and middle frame video generation. In our basic LTX RDRSN tutorial, we highlighted three workflows: the native ComfyUI workflow, the one provided by Kijai, and the ggov workflow. In today's video, we're going to focus on the second one, Kijai's workflow, to help you achieve video generation using first, middle, and last frames. To do this, we need a very important extension called Kijai Nodes. Many of you are probably familiar with it already. Just make sure you update it to the latest version. Just a quick heads up. Kijai is continuously updating his nodes for the LTX RDRSN model. Recently, he updated both the distilled and non-gen distilled versions of the model. I highly recommend keeping an eye on the input scale vfeed version. Due to time constraints, I haven't fully tested it yet, but I personally feel this model is going to bring us some pleasant surprises. Today, we'll focus on two specific setups: generating video from just the first and last frames, and generating video using the first, middle, and last frames. To make the demonstration easier, I've deployed these workflows on Running Hub. In the ComfyUI space, Running Hub is a fantastic online cloud platform. Whenever new models and tech drop, they're always the first to support them. It also provides a great online community for ComfyUI creators, where you can find tons of inspiration and smooth running workflows. Alright, let's start by looking at how to generate a video using the first and last frames, whether you are using just the start and end frames or adding a middle frame into the mix. We can collectively call this reference generation. And the core of reference generation is simply modifying the latent. I'm going to show you two different methods to modify the latent. Let's look at the first method. Before we break down the workflow, let's check out the result. I have two reference images here showing an Asian girl in a bedroom doing two distinct actions, one sitting on the floor and the other lying down on the floor. The visual difference and recognition between these two actions are very strong. Let's look at the generated video. You'll notice the entire movement flows perfectly in a single continuous shot. There are no abrupt scene cuts in the middle. This is our absolute ideal state for first and last frame video generation. To achieve this, we use a specific node to access it. You must have the Kijai Nodes extension installed that we mentioned earlier. This node is called Image to Video Inplace. Its job is to directly replace the keyframes inside the latent. To use this node, we have to feed it our VAE and the original empty latent, so it can perform the replacements. You can replace up to 5 images within the latent using the image 1 through image 5 inputs. Below those, you'll see corresponding index numbers and strengths. The index tells the node exactly which frame in the latent you want to overwrite. Just remember, the first frame is index 0. So, if your total frame count is 121, your last frame's index will be 120. Alternatively, you can just set it to -1 to automatically target the very last frame. The strength simply dictates how strictly the model should adhere to the reference control. The node outputs a single modified latent. This latent will then combine with our audio latent to form the final data for sampling. All you need to do is swap out the standard image to video in place node in our native workflow. With this one, keep in mind that all images must be scaled and compressed before entering this node. We already have the corresponding pre-processing nodes set up earlier in the chain. Since the ComfyUI LTX 2.3 workflow uses a 2-stage process-based video generation and then video upscaling, you'll actually see 2 of these image to video in place nodes. Through my testing, I found that you only need to replace the node in the first sampling stage. There is no need to replace it in the upscaling stage, because the basic composition is already locked in. The upscaler only tweaks details and won't affect the overall framing. This makes setting up the overall workflow much simpler. Now, let's talk about something incredibly important: prompt generation. If you just write a simple prompt like we used to with older video models, something like best quality dynamic motion, you generally won't get great results. This is especially true here because we are also generating audio. You really need a comprehensive, detailed prompt to get the best outcome. But let's be honest, writing prompts for start and end frames isn't exactly easy. To solve this, I've designed a prompt engineering template for you. You can use any large language model, drop this template in, and have it write the prompts for you. Let me demonstrate using Google AI Studio. Start a new chat, switch the model to the latest Gemini 3.1 Pro, and paste our prompt engineering template into the system instructions. Then, give the AI a subject. Keep an open mind here. Your subject doesn't have to be just text. It can be an image or even multiple images. Here, I'm uploading our two reference images, the first and last frames of our video. Then I tell the AI, please generate the corresponding LTX prompts based on these two images. Just like that, you get a fully detailed prompt containing both the video description and the audio description. Just paste this generated text into our ComfyUI workflow, and you'll get an amazing video. Let's check the result.
Right here is perfect.
We've seen this effect already, a flawless, one-take continuous video. Besides the node we just covered, Kijai provides another similar node called LTX Add Guide Multi. Its function is similar to the Inplace node we just used, acting as a form of reference generation, but there is a key difference. If you look closely, the inputs are basically identical, but the outputs are different. Instead of just outputting a latent, the Add Guide multi-node also outputs a positive condition and a negative condition. This means the node isn't brute forcing a latent replacement. Instead, it is adding extra constraints to the latent. It still controls the latent effect, but in a much softer, gentler way. I know this sounds a bit confusing, so let's demo this workflow. The inputs up front are basically the same. We send the output latent to our sampler. We also take the two condition outputs and connect them to our LTX condition node. Now, our conditioning is made up of two parts, one driven by the text prompt, and the other driven by our reference images. The rest of the workflow is identical to the previous one. Let's check the generated result.
Right here is perfect.
Obviously, this isn't a single continuous shot. There are noticeable camera cuts in the middle. Many of you might ask, does this still count as first and last frame generation? Actually, this is just a slight misunderstanding. This is absolutely still first and last frame generation. It just uses a multi-camera editing style instead of a one-take continuous shot. In video generation, multi-camera sequences are often exactly what you need. If the images are highly similar, this control method can also produce a one-take video. Through this demo, you should feel the difference between the two nodes. One enforces a hard runtime replacement. The other strengthens constraints. You can choose the node that best fits your actual application needs. Next, let's add a middle frame into the mix. It is actually super simple. We just swap our two reference images for 3. Then, we map them to the corresponding frames. Frame 0, frame 120, and frame 60. You can appropriately tweak the strengths as well. Usually, we set the first two a bit lower, like 0.6 and 0.7, and leave the last one at 1.0. For this test, I directly used the Inplace node to guarantee strong constraints. I picked my 3 images and used the prompt generator we discussed earlier to get the text. Let's look at the result. Clearly, it is not a one-take video. There are cuts. The reason is simple. As you add more images, the creative space left for the video generation model shrinks. If the 3 images aren't extremely similar, the model easily defaults to scene transitions. Let's verify this. Notice how the 3 images differ wildly in camera angle, character pose, and overall environmental similarity. Because of this massive variance, we didn't get a continuous shot. But I want to remind you, as I mentioned before, multi-camera cuts often deliver a fantastic viewing experience. Whether a video is good or bad doesn't really depend on it being a single continuous take. So, how do we force a one-take video with 3 frames? It is simple. Just ensure the similarity between the 3 images is extremely high. Take these three images of a beautiful girl standing by the sea as an example. The overall similarity is incredibly high. The first image is a static shot of her standing at the beach. In the second, she raises her hand to touch her hair. In the third, she points into the distance. Aside from that, the background perspective and everything else remain practically unchanged. Let's run this through the exact same workflow. Look at the final video. We get an absolutely stunning, seamless one-take shot. Through our exploration of image generation today, you can see just how powerful the LTX 2.3 model is when it comes to reference generation. I personally think it is much easier to use than the WAN 2.2 model, and the characters look much more natural. Remember, your goal isn't to memorize every single node in the workflow, but to truly understand the fundamental principles of reference generation. Once you grasp that, you'll know exactly how to tweak things to get the exact video you want. All right, that is all for today. What are you waiting for? Go try it out yourself. Follow me to become someone who truly understands AI.